Alright, this video is on second derivative implicit derivatives. If you remember, an implicit derivative is when your equation is not solved for y, but you still take the derivative anyway, ending up with y prime, and then eventually solving for y prime. Now what we're going to do is we're basically going to take our y prime equals and find the derivative again. So, second implicit derivatives. To find the second derivative, i.e. y double prime, first do a regular implicit derivative. Then do a derivative of the derivative, and you will end up plugging in y prime into that somewhere. And as a side note, very often the second derivative simplifies way down using the original problem or the original derivative. Okay? Using the original problem or the original derivative. Alright? Let's look at what this actually means. So here's our example. X squared plus y squared equals 4. First thing we're going to do is we're going to take our first derivative. Alright, our first derivative, we're going to have 2x plus 2y, y prime equals 0. Solve for y prime as usual. So we'll subtract the 2x, so 2y, y prime equals negative 2x. Divide off the 2y. The 2's cancel. So y prime equals negative x over y. Now what we're going to do is we're going to take the second derivative. Alright, and we're going to take the derivative of negative x over y. Alright, so negative x over y. The derivative is, remember, you have to do low, because this is quotient rule. You do low d high minus high d low. And the derivative of y is 1 y prime over the bottom squared. Alright, so let's simplify this down a little bit. Negative y plus xy prime over y squared. Now, what we're going to do, okay, now what we're going to do is we're going to take our negative x over y and substitute it in for y prime. Alright, we're going to substitute it in for y prime. So we're going to have negative y plus x times negative x over y over y squared. Alright, now to get rid of this fraction here, what we can do is we can multiply the entire top by y. And whatever we multiply the top by, you have to multiply the bottom by as well. Because, multiplying by y over y, we're essentially multiplying by 1, so we are not changing the value of the fraction. Alright, so now distribute the y through to both sets of parentheses. You get negative y squared minus x squared, because the y here and the y in the bottom will cancel out, leaving you x times negative x, which is negative x squared, over y cubed. Alright. Then you go back and, let me find it, where was it? We have x squared plus y squared equals 4. So if you look, if we factor out a negative, we have x squared plus y squared over y cubed. Alright, well if you go back up, you notice that we have x squared plus y squared equals 4. Well, here's x squared plus y squared. So this is negative 4 over y cubed. And that is the second derivative of x squared plus y squared equals 4. It is negative 4 divided by y cubed. All right. So remember how I said it can usually be simplified using the original problem? So we took the derivative, we used that derivative, substituted it in for y prime, and then when we got done, we factored out the negative to get x squared plus y squared, and then of course we prove, and then of course our original problem says, well, hey, x squared plus y squared is 4, Jack. So we substituted in the 4 and got negative 4 over y cubed. All right. So now I want you to try one. I want you to find the second derivative of xy plus 3x equals 5. So pause the video and work this out. All right, so let's find the first derivative. And that's going to be, let's see, this is product rule here. So we have, so this is 1 and this is 2. So you have 1 d2 plus 2 d1 is just 1, so I'm just going to leave it as y. All right, and then plus derivative of 3x, which is 3, equals 0. We got to solve for y prime, so subtract the y and subtract the 3 from both sides. So x y prime equals negative y minus 3. Divide off x, divide off x. So y prime equals negative y minus 3 over x. All right, so there's our first derivative. Now we got to find our second derivative. So we're going to find the derivative of negative y minus 3 over x. All right, let's go. So we know it's low times the derivative of the top, which is negative y minus 3, while the derivative of negative y is negative 1 y prime, so negative y prime, because the derivative of the minus 3 is just 0, so you don't have to worry about it, minus high, derivative of the bottom is just 1, over the bottom squared. So that's negative x y prime plus y plus 3 over x squared. Now what we're going to do is we are going to substitute in the negative y minus 3 over x for the y prime. Let me extend this a little bit. So now we're going to have negative x times minus y minus 3 over x, and then plus y plus 3 over x squared. All right. Now, since we have negative x times this, since this x and this x cancel out, leaving you now with negative times this, so it's going to be y plus 3 plus y plus 3 over x squared. So that's 2y plus 6 over x squared. And if we go back up and look at our original problem, we have xy plus 3x equals 5. Here we have 2y plus 6 over x squared. So in this case, we can't substitute back in our original problem. So this is our second derivative. This equals y double prime. All right. So second implicit derivatives are just a step. We just add a step or two to the regular implicit derivatives. So you just take the derivative of your derivative and substitute in y prime and then solve and then simplify it down from there. All right? Make sure you understand this and see you tomorrow in class.